So before we slowly move towards the ocean and climate change, we will introduce a few more concepts so that we are very clear on how things happen, what's the ocean's role, what's the impact on the ocean, physical impact, biological impact, chemical impact, and so on, to get a sense of how much warming can be important or impactful. We can look at the temperature change global mean or some evidence of more local changes. Nonetheless, how temperatures have changed since the last ice age ended about 12,000 years ago, and how these temperature changes have had an impact on civilizations along the way. Okay, so the last ice age started around 120,000 years ago, and the glaciers kept building, and we'll see how that happens. The orbital forcing changed around 20,000 years ago to 18,000 years ago, when the peak glaciation was reached, and then the glaciers started to melt and retreat. So the warming and deglaciation started around 18,000. There were a couple of hiccups along the way. There was a bit of a refreezing, change in the meridional overturning because of fresh water release from the glacier melt, and so on. By 12,000 years ago, we were into the current period, or the period that just ended, called the Holocene. I said we are currently in the Anthropocene. We won't define exactly when it started, but you can think of it as the Industrial Revolution marking the demarcation. So there were a little bit of oscillation around the current mean temperature of 15 degrees centigrade, global mean. Remember our energy calculations from the greenhouse effect, sun's energy being received, outgoing long wave, etc. So there is evidence that 9,000 years ago, for example, the Sahara desert that's currently a desert was actually quite green. Civilizations had moved west and east from the Nile River and exploited the water that was available because of this greenery and possibilities of doing living by hunting, gathering, and so on. And slowly agriculture evolved over this time in the last 10,000 years as hunters, gatherers became more agriculturalists and pastoralists and so on. The migrations and wanderings reduced. This is purported to have increased fertility rates, brought about monogamy. All sorts of hypotheses are there with some evidence. Nonetheless, the temperatures continued to warm, and around 8,200 years ago there was another hiccup. As you can see, little warming, then cooling, warming and cooling, and so on. And the warming lasted for a couple of thousand years after that, into the 7th century. It's called the Holocene optimum. Basically, during that time, Neolithic era would have been coming close to an end. You were having many civilizations, many advances, and then again a little bit of a cooling. The Holocene optimum continued. Things like Stonehenge construction happened around that time. As far as we know, Judaism and probably Hinduism go back that far, 3,000, 5,000 years ago. And several empires became dominant in some parts, the Roman Empire, the Roman climate optimum, and so on. So there are historical evidences, archaeological evidences, geological evidences, sediment evidences, and even recorded histories which tell you that these things happened. We have already talked about crossing the ocean, early explorers going back to 4500 BC, early maps, Library of Alexandria burning down, and so on and so forth, right? All those things happened. Why am I showing this? Because these little warmings, 1 to 2 degrees, were enough to cause plenty of changes in civilizations, extinctions of civilizations, movements, large-scale movements of civilizations abandoning land, moving closer to the Nile, for example, around 2500. This cooling here, you would have had the Mohenjo-daro Harappas facing severe monsoon droughts for a couple of hundred years and going extinct, and so on, right? So there are plenty of evidences that climate change has had serious impacts on human civilizations. Coming into the last couple of millennia, you can see that the medieval warm period started, and it has the most important thing we know about it, for example, is the expeditions of the Vikings onto Iceland, Greenland, all the way into North America. We looked at this a little bit before. Greenland had melted on the coasts enough to allow agriculture, so colonies were built. And around 1,000 years ago, in the last millennium, the medieval warm period ended. We will see that was related to potentially a increased number of volcanoes. Volcanoes tend to put a lot of dust, especially into the stratosphere, which blocks the energy coming in and cools the temperatures. There are things like the year without the summer because of the Indonesian volcanic eruption, loss of crops. We saw even Edvard Munch's The Scream coming out of the fantastic sunset set up by the aerosols spewed by the volcanoes and so on, right? So that led, along with the minimum sunspot activity, we will see how that affects climate and energy coming in, created what is called a Little Ice Age. Was not global, restricted mostly to parts of Europe, with plenty of records showing how civilizations got affected, how crops and climate and even alcohol brewing got affected, and so on. And the Little Ice Age ended just as the Industrial Revolution started, and now we are in this global warming era that we are focused on in this chapter, right? So the main point is that the Holocene has been fairly benign in terms of the temperature changes compared to some of the bigger swings we saw going back to 65 million years, right? So the modern human being and all the Bronze Age, Iron Age, end of the Stone Age, into the Industrial Revolution to the present has all happened during this fairly minimum changes in global temperatures. So the question then is, are we so resilient to changes in temperatures that even big temperature changes will not affect us so much? That's a critical question, right? That's something we must understand. So we need to understand how climate responds, how sensitive it is to changes in either the energy coming from the sun or the changes in carbon dioxide, plate movements, whatever is causing the energy balance change. We need to know that because, as I said, we are kicking the system and we don't know how quickly it can change and what feedback can kick in that can produce very rapid changes which will be difficult to adjust to, right?